Now next is Silo's third theorem. This is very important. The number of silos P subgroup of G denoted by NP, which is congruent to 1 mod P, or NP is equals to 1 plus KP. Moreover, NP divides order of group G. Number of silos P subgroup of G, it is denoted by NP, and NP is equals to 1 plus KP. Any unique silo P subgroup of G is normal in G. If NP is equals to 1, then the silo P subgroup is normal in G. Now next is some applications of Silo's theorem. First, let order of G is equals to 2P, where P is an odd prime. Either G is isomorphic to Z2P or G is isomorphic to dihedral group. So whenever we have a group whose order is 2P type, where P is an odd prime, then either G is isomorphic to Z2P or it is isomorphic to dihedral group. Second, let order of G is equals to PQ, where P and Q are primes. P is less than Q and P divides Q minus 1. Then G is cyclic and G is isomorphic to ZPQ. Third, let order of G is equals to 12. Then G has either a normal silo 3 subgroup or G is isomorphic to A4, because order of A4 is also 12. If order of G is equals to 60 and G has more than one silo 5 subgroup, then G is simple. Now what do you mean by simple groups. A group G is said to be a simple group if it has no non-trivial normal subgroup. So I can relate to this that any unique silo P subgroup of G is normal in G. और सिंपल होने के लिए उसके पास नॉन ट्रिवियल नॉर्मल सब ग्रुप नहीं होना चाहिए. सो दिस मीन्स दैट देयर शुड बी मोर देन वन साइलो पी सब ग्रुप, देन ओनली इट विल बी नॉट नॉर्मल, सो देन इट विल बी सिंपल. नेक्स्ट, नॉन simplicity test. How to check whether the group is simple or not. Non simplicity test. First, odd test. If order of group G is equals to 2n, where n is an odd number greater than 1, then G is not simple. For example, let order of group G is equals 210, then G is not simple because its prime factorization is 2 into 3 into 7 into 5. So 2 into 3 into 7 into 5. It is of this type only. This is 2 into 105. 105 is an odd number greater than 1. Therefore, by odd test, G is not simple. Second, index theorem. If G is a finite group and H is a proper subgroup of G, such that order of G does not divides index factorial, then H contains a non-trivial normal subgroup of G in particular. G is not simple. Next is embedding theorem. If a finite non-abelian simple group G has a subgroup of index n, means G is a finite non-abelian simple group which has a subgroup of index n, then G is isomorphic to a subgroup of An. Some remarks. First, An alternating group. This is simple for all n greater than equal to 5. Next, any simple group of order 60 does not have a subgroup of order 30. Any simple group of order 60 does not have a subgroup of order 30. Another example of converse of Lagrange's theorem. So let us see its small proof also. Let G be a simple group of order 60 so we need to prove that it does not have a subgroup of order 30. If we suppose that it has a subgroup of order 30, if possible, suppose that H is a subgroup of G such that order of H is 30, then index will be order of G upon order of H, 60 upon 30, which is 2. Whenever index is 2, then H is a normal subgroup of G. But we are given that G is simple, so it cannot have any normal subgroup, but G is simple. So we get a contradiction. Therefore, our supposition is wrong. Hence proved. Next, let G be a simple group of order 60. Then G is isomorphic to A5. Next, A5 does not have a subgroup of order 20. Let us prove this also. Let, if possible, suppose that H is a subgroup of A5 such that order of H is equals to 20. Now index will be order of G upon order of H, order of A5, which is 60 upon order of H, 20. This is 3. So order of G does not divides Therefore, by index theorem, H contains a non-trivial normal subgroup of A5. But this is a contradiction because A5 is simple. As A5 is simple, therefore A5 does not have a subgroup of order 20. Next, An does not have a proper subgroup of index less than n for all n greater than equal to 5. An does not have a proper subgroup of index less than n for all n greater than equal to 5. So A5 does not have a subgroup of index less than 5. We have seen here also that A5 does not have a subgroup of index less than 5. Here index was 3. So let it possible. Suppose that H is a subgroup of An such that index of this is equal to m, which is less than n. Therefore, by embedding theorem, what was embedding theorem? If a finite non-abelian simple group G has a subgroup of index n, then G is isomorphic to a subgroup of An. Here An is a finite non-abelian simple group which has a subgroup of index n. So G will be isomorphic to a subgroup of An. Therefore, by embedding theorem, An is isomorphic to a subgroup of Am So this means that order of An divides order of Am. This implies n factorial upon 2 divides m factorial upon 2. This means that n factorial divides m factorial. But m is less than n. So this is not possible. So this is a contradiction. Therefore, our supposition is wrong. Hence proved. Next, An is generated by the set of all 3 cycles for all n greater than equal to 3. Seventh, the order for simple groups within 200 are 60 and 168. Now let us discuss some questions based on Silo theorem. First question. Prove that group of order 30 is not simple. So firstly, order of group G is 30. Its prime factorization will be 2 into 3 into 5. So this is a 30 order group. So it will have silo 2 subgroup, because I have told you that it is silo P subgroup. So silo 2 subgroup, silo 5 subgroup, 3 subgroup, then 5 subgroup. Silo 5 subgroup. So by Silo's third theorem, which is NP is equals to 1 plus KP. So this will become N2 is equals to 1 plus 2K. And this implies that 1 plus Kp divides order of group G. So this means that 1 plus 2K divides 15. अब इसमें क्या होगा, आपके पास जो भी ऑर्डर है ना, जैसे ऑर्डर 30 था हमारे पास, जब मैंने उसमें साइलो 2 सब ग्रुप देखा तो इसमें आप 2 वाला फैक्टर छोड़ के बाकी जो बच गया 15 वो यहाँ लिखोगे. ये क्लियर हुआ? जब N2 लिखना है तो जो फैक्टर बच गए हैं सिर्फ वो लिखेंगे, यहाँ पे पूरा 30 नहीं लिखेंगे. क्लियर हुआ?
Yes, ma'am.
Okay. So what will be the values of K? K will be
1 and 7.
0 is also possible, no?
Yes, 0 is also possible.
1, 2 and 7. So this means that N2 can be 1, 3, 5 or 15. Similarly, N3, this is equal to 1 plus 3K. This means that 1 plus 3K divides 10. So K can be 0, K cannot be 1, K cannot be 2, K can be 3. So N3 is equals to 1 or 10. N5, this is equal to 1 plus 5K. 1 plus 5K divides 6. So K is 0 or 1. So N5 is equals to 1 or 6. Now I will consider that Nk whose possibilities are less. There are 4 possibilities, so I will consider this one. If n3 is equals to 1, then clearly G is not simple, because I have told you that if we have unique silo P subgroup, then it has normal subgroup, and if it has normal subgroup, then it cannot be simple, because it will contradict the definition of simple group. Is this clear?
Yes, ma'am.
Now if n3 is equals to 10, means there are 10 silo 3 subgroups. So H1, H2, so on till H10. These are 10 distinct silo 3 subgroups of G. And each has order 3. Order of Hi is equals to 3 for all I. So Hi will contain which type of elements? It will definitely have one identity, because it is a subgroup, and rest of the elements can be like Ai and Vi. It can be anything. So this one identity has order 1, and rest of the elements will have order 3. Now if I is not equal to j, then Hi intersection Hj, this is contained in Hi, also this will be contained in Hj, because intersection of two subgroups is again a subgroup. We have studied this many times now, that H1 intersection H2 is contained in H1 also and H2 also.
Yes, ma'am.
So now order of Hi intersection Hj, this will divide order of Hi, and order of Hi is 3. So order of Hi intersection Hj is equals to 1 or 3. So I have already taken that I is not equal to j. For example, if A is not equal to B, if A and B are two subgroups which are not equal, but their cardinalities are same, and also cardinality of A intersection B is equals to order of A. So this implies that A intersection B is equals to A, and A intersection B is equals to B. So A is equals to B, which is a contradiction. So order 3 is not possible. In short, order of Hi intersection Hj cannot be equal to order of Hi. So we will have that order of Hi intersection Hj is 1. So how many elements of order 3 will be here? Order 3. If I have H1 subgroup, then it will have only 2 elements of order 3. So there will be total 20 elements of order 3, because there are 10 silo 3 subgroups. So there are 20 elements of order 3. Next, if n5 is equals to 1, then clearly G is not simple. If n5 is equals to 6, then there will be 6 distinct silo 5 subgroups of G. K1, K2, K3, K4, K5, K6. These are 6 distinct silo 5 subgroups of G. So order of Ki, not order, Ki will be like this: identity, Ai, Bi, Ci, Di. So identity has order 1 and rest of the elements will have order 5. So can you tell me how many elements of order 5 will be here? By the same approach we have done
4,
here.
6, 24.
Yes, there will be 24 elements of order 5. So total how many elements will be there? 24 and 20. 44 elements. 20 elements of order 3 and 24 elements of order 5. Total 44 elements. Is this possible? Group has order 30. Not possible, na? Because order of group is 30. So this means that either n3 is 1 or n5 is 1. Then we will have unique silo P subgroup, means it will be normal. So it is not simple. Therefore, either silo 3 or silo 5 subgroup of G is normal in G. Hence, G is not simple. So any group of order 30 is not simple. Next question. Prove that any group of order 12
मैम इसको डायरेक्टली और टेस्ट से भी कर सकते थे ना,
is not
लाइक ऑर्डर ऑफ डी इज 2n.
2 into 15 उससे भी कर सकते हैं, बट ना काफ़ी बार क्वेश्चंस में इस तरह से पूछ लेते हैं कि इसके पास साइलो 2 सब ग्रुप कितने हैं या साइलो 3 सब ग्रुप कितने हैं, तो उसके लिए ये अप्रोच आनी ज़रूरी है. क्योंकि यहाँ पे जैसे ये 12 वाला है, अब यहाँ पे तो ऑड पी टेस्ट नहीं लग पाएगा ना. 12 की करेंगे तो 2 into 6 2 into 3 यहाँ पे नहीं लग पाएगा. ये आपको ट्राई करना है कि मैं कर पाऊँ? एक बार ट्राई कर लो तो अच्छा है. वैसे
ट्राई कर लो.
ठीक है, कर.
इसमें तो तीनों केस में k की वैल्यू 0 और 1 आएगी, और अगर 1 है तो सिंपल ही नहीं हुआ, फिर n2 क्या हो जाएगा, 3 और
So 12 is equals to 2 square into 3. So there will be silo 2 subgroup and silo 3 subgroup. Silo 2 subgroup has order 4. And silo 3 subgroup. So n2 is equals to 1 plus 2k. So 1 plus 2k divides 3. So k will be either 0 or 1. So n2 is 1 or 3. n3 1 plus 3k. 1 plus 3k divides 4. So k will be 0 or 1. So n3 is 1 or 4. Now if n2 is 1, then G is not simple. If n2 is 3, then there will be 3 distinct silo 2 subgroups of G. Order of HI, this is 4 na, because it is silo 2 subgroup of order 4. So HI will have elements like identity, AI, BI and CI. So this will have order 1 and rest will have order 4. So again order of HI intersection HJ divides order of HI, which is 4. So order of HI intersection HJ, this is equal to 1, 2 or 4. Now here we have 3 possibilities. So instead of seeing these possibilities, I will go to this n3, क्योंकि हमें वहाँ से सॉल्व करना है जहाँ से हमारा जल्दी सॉल्व हो जाए. इसकी पॉसिबिलिटीज़ देखने में हमें टाइम लग जाएगा नहीं तो. दिस इम्प्लाइज G इज़ नॉट सिंपल. If n3 is equals to 4, this implies k1, k2, k3, k4. These are 4 distinct silo 3 subgroups of G. So order of HI, this is 3. Order of HI intersection HJ divides order of HI, which is 3. So again order of HI intersection HJ, this is 1 or 3. Again 3 is not possible. So how many elements of order 3 will be here?
Here will be 3, 4, 12.
12. Order 3. This
हाँ,
has
सारे ऑर्डर 3 के होंगे ना, 12 ही हो गए पूरे. अच्छा ये 4 है, नहीं ठीक है, 4 और 12 भी आएंगे पूरे.
नहीं, आइडेंटिटी का तो ऑर्डर 1 है ना.
अच्छा 2, 3 या 6 हो गए थे.
नहीं, H1 के पास 2 एलिमेंट्स होंगे ऑर्डर 3 के. तो
सेम सबके पास होंगे ना?
हाँ, तो 2 into 4 8 हुआ ना?
8 हुआ.
8 elements of order 3. Hence true. Next question. The number of silo five subgroups of S6 is
Five subgroups.
A part 16, B part 6, C part 36, D part 1. Try this.
36 है इसका आंसर.
So order of S6, 6 factorial. So its prime factorization will be 2 to the power 4, 3 square into 5. But I need only number of silo 5 subgroups. So N5, this is 1 plus 5k, which divides 2 to the power 4 into 3 square. Means 1 plus 5k divides 144. So k can be 0, 1, 3 or 7. So accordingly N5 can be 1, 6, 16 or 36. Now if N5 is 1, so how many, so it is obviously silo 5 subgroup. How many elements of order 5 are there? If I have only one silo 5 subgroup, then it will have 5 elements because its order is 5. So how many elements of order 5 will be there?
4 is there.
Yes, 4. If N5 is 6, then how many elements of order 5?
5.
5. If N5
5
is
is
6 means that H1, H2, H3,
H4,
H5,
H5,
H6
6 हुए.
कितने एलिमेंट्स होंगे ऑर्डर 5 के?
6.
नहीं, आप सही नहीं जा रहे. देखो H1 है तो इसका मतलब इसके पास 5 एलिमेंट्स हैं टोटल. इसमें H1 में 5 एलिमेंट्स हैं. एक आइडेंटिटी, एक A1, B1, C1, D1 इस टाइप के. उसमें से आइडेंटिटी हैज ऑर्डर 1 and rest of the elements have order 5. So H1 has 4 elements of order 5. So these 6 subgroups will have total
24.
24. If N5 is 16, then मतलब सिंपली ऐसे देखो कि ये N5 है, इसमें से एक कम कर दें तो 4 बचा. 16 इंटू 4 64. If N5 is 36, then it will have 36 into 4, 144 elements of order 5. So अभी भी नंबर ऑफ साइलो 5 सब ग्रुप्स इतना सब करके हमें कंफर्म नहीं पता चला है. तो उसके लिए हम क्या करेंगे, एलिमेंट्स ऑफ ऑर्डर 5 इन S6 जो मैंने फॉर्मूला बताए थे नंबर ऑफ लेंथ ऑफ साइकिल वाले, वो वाला फॉर्मूला यूज करेंगे. दिस साइकिल बिलोंग्स टू S6 एंड सिग्मा इज अ 5 cycle. So what was the formula? N factorial upon R factorial, N minus R factorial, and R denotes length of cycle. This was Sn. So here it will be 6 factorial upon 5 factorial. Sorry, R into N minus R into 6 minus 5 factorial. So 6 into 5 into 4 into 3 into 2 into 1 divided by 5. So 24 into 6, 144. So I was getting this 144 elements in this N5 equal to 36. So there are 36 silo 5 subgroups. So answer is option C. Is this clear?
36 यहाँ पे कैसे आया?
अब यहाँ पे हमें साइलो 5 सब ग्रुप पूछे हुए थे और जो ये चारों पॉसिबिलिटीज आई हैं ये चारों ही ऑप्शन में गिवन है ABCD में। तो फिर मैं 36 को कैसे टिक करूँ? उसके लिए मैंने क्या करा, यहाँ पे 144 एलिमेंट्स आए थे हमारे पास, मैंने ये चेक करा एलिमेंट्स ऑफ ऑर्डर 5 इन S6, ये वाला फॉर्मूला हमने पढ़ा था ना, तो उसको अप्लाई करा तो उसमें आया 144 एलिमेंट्स। फिर मैंने देखा कि कौन सी वाली पॉसिबिलिटी में 144 एलिमेंट्स हमारे पास आ रहे थे।
अच्छा, ठीक ठीक।
तो उससे मैंने टिक करा, अदरवाइज तो ये चारों ही ऑप्शन टिक हो नहीं सकते। ठीक है। नेक्स्ट, the number of silo 5 subgroups in a group of order 45 is
आंसर कैन बी इधर 4 एलिमेंट्स आएगा, फिर डी ऑप्शन आएगा इसका आंसर।
नंबर ऑफ एलिमेंट्स नहीं बताने, नंबर ऑफ साइलो 5 सब ग्रुप्स बताने हैं।
फिर 1 आएगा ए।
यस, ऑर्डर ऑफ ग्रुप G is 45, its prime factorization is 3 square into 5, so n5 this is equal to 1 plus 5k, 1 plus 5k divides 9, so k can be either 0, k can be only 0 only. So n5 is 1, so unique silo 5 subgroup, so answer is option A. Next, let G be a group of order n which Which of the following conditions imply that G is abelian? A part n is equals to 15, B part n is equals to 21, C part n is equals to 36.
ये MSQ है या MCQ है?
MCQ.
तो फर्स्ट ए का ट्रू है फिर।
Yes. What was your approach?
The prime factor जिसमें 15 is 3 into 5 and 3 does not divide 4, 5 minus 1.
Yes. 3 does not divide 5 minus 1. P does not divide Q minus 1. So group is cyclic and every cyclic group is abelian. And for B part, n is equals to 21. This is 3 into 7. So 3 divides 7 minus 1. So either group G can be cyclic or it can be non-abelian. So option B is discarded because it can be non-abelian also, na? C part, n is equals to 36. Can you tell me any group of order 36 which is non-abelian? ये हमने पढ़ा हुआ है.
हाँ मैं वही रिकॉल कर रही हूँ.
मतलब अगर कभी नॉन एबिलियन हमें चाहिए हो तो सिंपली याद रखो सिमेट्रिक ग्रुप, डाइहेड्रल ग्रुप लिमिटेड से हैं. तो यहाँ पे कौन सा वर्क कर जाएगा?
डाइहेड्रल 2p.
यस. से हो जाएगा ना D36 एंड इट हैज ऑर्डर 2 into 18. So this is a non-abelian group. So answer is option A. Next question. Let G be a group of order 45. Let H be a silo 3 subgroup of G and K be a silo 5 subgroup of G. Then A part, both H and K are normal in G. B part, H is normal in G, but K is not normal in G. C part, H is not normal in G, but K is normal in G. D part, both H and K are not normal in G.
इसमें जो अभी हमने किया ही था ऑर्डर 45 वाला 5 साइक्लोग्राफ वाला, तो उसका जो मीन्स जो के ग्रुप है वो तो नॉर्मल ही होगा इन जी में, क्योंकि उसका 1 था। ठीक है ना, नंबर ऑफ साइलो 5 ग्रुप 1 था, तो वो तो नॉर्मल ही हो गया। बाकी एच वाला चेक करती हूँ मैं। तो एच में हम ऐसे कर सकते हैं कि इसका ऑर्डर जैसे 3 स्क्वायर है ना, तो ऑर्डर 2 के 3 ऑर्डर 2 के 3 साइलो सब ग्रुप हो गए ना। मैं करती हूँ, ऑर्डर 2 है तो प्राइम ऑर्डर करके कर सकते हैं इसको, कि प्राइम ऑर्डर है तो
नहीं,
वो साइक्लिक।
देखो ये है साइलो 3 सब ग्रुप ऑफ ऑर्डर 9।
ऑर्डर
9 3 स्क्वायर है ना,
हाँ,
तो ऑर्डर 9 होगा। जैसे अगर कभी 2 स्क्वायर होता तो वो
अच्छा 2 का स्क्वायर था 4 किया था हमने, ठीक है, ऑर्डर 9 हुआ। तो ऑर्डर 9 को हम 3 स्क्वायर कर सकते हैं, तो 3 स्क्वायर हो गया। तो पढ़ा है ना कि अगर ऑर्डर पी स्क्वायर है तो वो एबिलियन होगा, एनी ग्रुप ऑफ ऑर्डर पी और पी स्क्वायर।
फिर से बताना आप किस साइड चले गए, एक बार फिर से बताना ये क्या पी स्क्वायर कैसे लिया है।
जैसे ऑर्डर 9 है ना, 3 साइलो सब ग्रुप ऑफ ऑर्डर 9।
हाँ, पर पहले तो बस ये पॉसिबिलिटीज देखो ना, जो प्रोसीजर मैंने बताया कि क्या होगा यहाँ से।
हाँ, एक मिनट करती हूँ। दोनों ही नॉर्मल आ रहे हैं फिर इसमें, एंड आ रहा है, दोनों नॉर्मल आ रहे हैं।
यूनिक सो नॉर्मल। मतलब ये जो साइलो वाला कंसेप्ट है ये काफ़ी अच्छा कंसेप्ट है, कंफ्यूजिंग नहीं है, छोटे से स्टेप है, और नॉर्मल के बारे में जल्दी पता लग जाएगा अगर यूनिक आ रहे हैं तो। सो आंसर विल बी ऑप्शन ए। क्योंकि जो वो आप पी स्क्वायर वगैरह कह रहे थे वो यहाँ नहीं कर पाओगे, उसका रीज़न ये है क्योंकि यहाँ साइलो का कंसेप्ट चल रहा है ना।
अच्छा, ठीक है।
तो यहाँ मेजरली आपकी साइलो थर्ड थ्योरम ही यूज हो रही है। ठीक है, फिर इसके बाद नेक्स्ट क्लास में कंटिन्यू करते हैं।
Okay, ma'am.